All right, supposed to be doing radical equations, but yeah. Oh, there we go. Okay, so we got our camera coming into play there. All right, how do you solve a radical equation? We'll make a simple one to start with. 5 square root of x minus 1 plus 6 is equal to 26. Okay, so what we want to do is just isolate the radical. This is the radical right there. So we want to move the 6. So 5 times the square root of x minus 1 is equal to 20. Now move the 5. Of course, you divide there. And eventually, we want to get to the point where the entire side is only the radical. Okay. Now, to get rid of the radical, we're going to focus on the index of that radical. Here's the square root. So the index is understood to be a 2. I'm going to raise both sides to the second power. Okay. On the left-hand side, that power is just going to get rid of the radical for you. On the right-hand side, you apply it, and then it's easy to finish. Okay. So x is equal to 17. All right. Now, had that been, sorry, the 17 down there. Had that been a cube root, of course, you just raise it to the third power. Had it been a fourth root, you'd raise it to the fourth power, and so on and so forth. Okay, so that would be x equals 17 in this case. As you can see there, the entire process. All right. Now, sometimes we may run into trouble. Zoom back in a bit. Things to watch out for. Let's say we have negative 2 square root of x minus 6 is equal to 30. Okay. If you have an even index, again, here for simplicity, we're just keeping it with a 4 because it really doesn't matter so much, if it's, or keeping it with a 2 rather. It doesn't matter what the index is so much. You do them all the same way. But if you have an even index, and once you isolate, if there's a negative right here, this is a no solution. Okay, so just be careful of that. Again, even right there, even if it was, say, the fourth root, same deal. You can't have an even with a negative. Okay, so just be aware of that piece. Sometimes you have radicals on both sides. Something, let's just say 27. Now, this is easy to deal with because they're already isolated. I'm just going to square both sides. Computer running out of juice here. Square both sides. And the radicals happen to go away at the same time, which is nice. Okay. Now I can just solve. Let's see, add 27. So x is equal to 6 in this case. All right, I apologize. This screen's just not quite big enough for me to show everything at one time. But again, if you get radicals on both sides, square both sides, the radicals go away at the same time, and then just solve wherever you have left. Okay. So that is that part. Okay. Let's look at one where you may have something like this. We have a radical on one side, a non-radical on the other. Okay, so again, we'll square here because this is isolated. This is going to focus or force you to square that entire side. Okay. So we'll distribute here. Slow down as you need if you want to pause the video or wherever. Okay. Now I'm going to move the X and the 24 over. All right. This is quadratic. Now, the reason we moved them over, if you ever have a quadratic equation, highest power 2, and you have X to the first with it, which is usually the case, you're going to want a 0 there. Okay, so either you can factor or use the quadratic formula, whichever. So here we're going to factor. I'm going to assume you know how to do that. X plus 8x minus 1. Okay, basically what multiplies to this and adds to that. Okay, now from here, we can set each one equal to 0. And solve. So I'm in view here. Now our problem here is we're going to have to reject one of these answers. We're going to have to reject the negative 8. Because if I put negative 8 back into the original equation, if I put negative 8 in there, negative 8 plus 4 is negative 4. And negative 8 in here is 16. All right. Remember what we said. You can't have a square root end up negative out here. So this is no good. If you check the 1, it's fine. The negative 8's not. Okay, so solving rational equations. Radical equations. Radical